got 1 out of the 3.
I got 0 out of the 3.
I didn't get this or
I
that.
got, okay, I got these. I just didn't get that one. Oh, yikes.
How do you know which problem we're doing?
Wait, did we do that?
How do you guys get that so quickly?
Oh, I
I
didn't get.
just searched
I
up
searched up
AP
the
Calc.
question.
Oh, you search up the question.
Yeah. I got 2 points.
Can see how to put units on this.
Yeah. I literally got 2 points. This is so
Guys.
sad.
I think I got a 0 then.
Oh, I got 1. I got 1.
I got this one and this one, but I got this one because I
Wait,
grabbed
Justin,
it.
did
I got
we
all
do?
of these, but I didn't put units.
This is 23. I got like 89.
Wait, why do you have to do 23?
What is this?
23 is the amount of.
I was thinking about that. I was like,
Wait, Mr. Park.
23.
Oh, I got 2 points.
I got 2 points too.
No,
Oh,
you
yes.
only put units when they ask for it.
Yes.
Anyway, don't worry about that until tomorrow. Let's worry about this now.
I saw this.
Okay, let's quickly go
So I
over
subtracted
this
from
quiz.
Oh, I
this.
didn't
So
want
I
to
didn't
do
know
that.
that's the when I added up the
Six.
So I was like, I'm not.
I got a 2.
Wait, if it has to be answered with justification,
I was
what if
like,
I
I'm
just
not
put 12
11.
and I don't put a
That's so
justification?
dumb.
LOL. Watch me get no
I
points.
didn't do the.
I get 1 point.
I got 1 out of 3.
I dropped it right so.
I'm gonna get 1 out of 9.
Okay, let's quickly do this. A. Okay, so the point of distribution for this problem was 2, 3, 2, 2. Okay, it says between 0 and 6. Oh, now I remember. You guys gotta be careful now. Find all times t during which particle r is moving to the right. So make sure you get the right one now. Here's the particle. Okay, so this is the position, right? So how do you tell if a particle is moving to the right or the left? You look at the velocity. So here is the velocity of particle r. Take the derivative of this. 3t squared minus 12t plus 9. Factor on a 3. T squared minus 4t plus 3. T minus 1. T minus 3. Make a number line. 1 and 3 plus minus plus. I forgot what it was. Left or right? Okay, when is it moving to the right? Well, the answer would be 0 to 1 and then 3 to 6. This is the correct answer. However, if you don't put the bracket, you put parentheses, we're going to give you the point. So that part I'm not worried about. The other part I'm worried about. Some people put 3 to infinity. That will lose the point. I think about 3 people put it. You cannot see because they're giving it to you on a specific domain. So you have to end it at 6 over there. You guys understand? Because we don't want to lose. 1 point could be the difference right there. So, yeah. So anytime they restrict the domain, you are strictly on the domain. You cannot go outside the domain. And if you don't know what symbol to write here, I told you guys, what should you do? If you don't know what symbol to write, put a comma. Because some people are putting and is technically wrong, but I think they would still give you the point. But come on, use a comma if you don't know.
Oh, I got 1 point.
Okay, so that was worth 2 points. Okay, B. For t between 0 and 6, find all times during which the 2 particles travel in opposite directions. So to determine which way the particles are moving, you got to make number lines. Now we already made a number line for the r particle. Now we got to make for the p particle. Okay, so what's the derivative of p?
P prime.
Okay, or you can put velocity, whatever. Anyway, how do you take the derivative of cosine? So leave the constant on the side. The derivative of cosine box is negative sine box times the derivative of box. Now, you gotta somehow make a number line for this. So velocity of particle p. When is sine equal to 0? It's 0, pi, and 2 pi, right? So what would make this thing 0? 0, right? What would make that thing pi? What would make this, what do I have to plug in for t to get pi? 4, right? Because if you plug in 4, you get sine pi, which is 0. That's what you put on the number line, what things that make it 0. And then what would make this 2 pi? 8, okay? And then the sine graph usually looks like this, right? So it's above and below, but then this is a negative sign. So if you for example, if you plug in like 2, this is gonna be 1, but then this is negative, so it's gonna be negative, positive. So, how do you tell when the particles travel in opposite direction? They have to have opposite signs on the velocity, right? So, look at these two number lines. Where do they have opposite signs on the velocity? That's why it's easier if you stack the number lines on top of each other. 0 to 1, because this one is plus, this means it's moving to the right, but over here it's moving to the left. And then, as well, 3 to 4. That was worth 3 points right there. So again, go back to things that you know. What do we know? We know how to make number lines. Okay, part C. Find the acceleration of the particle P at time equal to 3. Okay, here's particle P. They want the acceleration. Well, this is, what is this? This is the velocity. So we need to take one more derivative then, right? So the acceleration of particle P, it doesn't matter what notation you write here. Throw the constant on the side. You don't even have to simplify that, yeah? The derivative of sine box is cosine box times the derivative of box. You don't even have to put pi over 4 squared. You can just leave it like that. And then they want you to, what number are we doing? We're doing C. At time equal to 3, so plug in 3. Negative 2 times pi over 4 times pi over 4 times cosine of 3 pi over 4. You can just leave your answer like that, you know. You don't even have to simplify. Okay, so that's 1 point right there, and then what does it say? Oh, is particle P speeding up, slowing down, or doing neither at time equal to 3? How do you tell if the particle is speeding up or slowing down? You look at the signs of the velocity and the acceleration. So here's the velocity right here. This is the velocity for particle P. Velocity of particle P at 3 would be, what happens when you plug in 3 into this? You get negative 2 times pi over 4 times sine of 3 pi over 4. Now, is this one here positive or negative? What is cosine? See, you don't even have to know what cosine 3 pi over 4 is. You just got to know that it's what? Is it positive or negative? It's negative. So, a negative times a positive times a positive times a negative, this is positive. And sine of 3 pi over 4 is what? Positive. So, positive times positive times negative is negative. So, if this is positive and this is negative, they have opposite signs. So, that means it's slowing down. Slowing down because the velocity and acceleration at 3, somehow you gotta indicate that, have opposite signs. That's what they wanna see. They wanna see your work and they want the sentence. That was 2 points. And then D, write but do not evaluate an expression for the average distance. Now remember, average means average value. So on the interval from 1 to 3, 1 over b minus a, integral from a to b of, now how do you find the distance between the two particles? Like for example, if this is 2 and this is 5, how do I find that distance?
Right minus.
Well, normally we go right minus left, but see, when the particles are traveling on the number line, how do you know which one's on the right and which one's on the left? So how do I indicate that? Can I just subtract? Yeah, you take the absolute value. It's the absolute value of P of t minus R of t dt. And it doesn't matter which way you subtract, right? Because we take absolute value. Think about it. The absolute value of 2 minus 5, is that equal to the absolute value of 5 minus 2? Yeah, it doesn't matter which way you subtract. If you put absolute value, that tells you the distance between the two things. See, but at least, if you wrote this part here, you get 1 point because you're using an average value formula. So you get 1 point for the average value formula, and the other point is, do you have the correct integrand there?
That's what it's called.
Yeah, the thing inside. Just like, if this is a radical, the inside of the radical is called the radicand. This is the integrand. All right. we should like go over it. Cause to me, the two hardest problems for students are rate problems and the graph problems that we have left. Well, are there any questions on the graph homework problems?
No. I hate graph.
You don't like graphs? Well, that's tomorrow's quiz, yeah?
Tables are worse.
So I think tomorrow's one, they're gonna ask you like the maximum value or something like that. You gotta have a candidate's test there. You gotta have a candidate's test. Okay, let's read this problem. This is your first problem on the homework. The rate at which rainwater flows into a drain pipe is modeled by this function. So this is number one, so that means you're gonna use a calculator. 20 sine t squared over 35. Make sure your calculator's in radian mode, yeah, whenever you use your calculator. Okay, from 0 to 8, that's probably gonna be important. The pipe is partially blocked, allowing water to drain out of the pipe at this rate. So notice that these are both rates now. 0.04 t cubed plus 0.4 t squared plus 0.96 t. Cubic feet per hour for 0 to 8. There are 30 cubic feet of water in the pipe when t is 0 at the very beginning. Okay, now without even reading the questions, somewhere during this problem, you're gonna have to do this. In fact, the amount of water in the pipe, maybe you should just do this at the very beginning, right? How do you tell how much water is in the pipe at any time t? Well, how much water is in there to begin with? What does it say? You gotta read. 30, there's 30 cubic feet of water in the pipe at the very beginning. So there's 30 in the beginning. Now, if this is the rate at which water is flowing into the pipe, how much water is in the pipe? I mean, how much water actually goes into the pipe? The integral from 0 to whatever of 20 sine, you know what? In fact, since it's defined on the paper, you can just do this, right? You don't have to write it all out. Right? If you are given a rate, how do you find out how much was done or accumulated? You integrate it, right? And if this is the rate at which water is coming out of the pipe, how do I figure out how much water came out of the pipe? So minus the integral from 0 to whatever time it is of dot dt. So somewhere in this problem, we're gonna have to rely on this right here. Because this tells you how much water is in the pipe at any time t. Like for example, what if they ask you how much water is in the pipe when t is 4? Then you would just put 4 here and 4 there, right?
Yeah.
Because the integral from 0 to 4 tells you how much, that's the amount of water that went in. This is how much water came out, right? Okay, okay, so all I'm telling you is somewhere, whenever you do rate problems, you're gonna have to do this somewhere in there. Okay, A. How many cubic feet of rainwater flowed into the pipe during the 8-hour time interval? Well, which of these rates is the rate of the water going into the pipe? R. So if you know what the rate is, this is the rate at which water flowed into the pipe. How do you figure out, I mean, the rate at which water is flowing into the pipe, how do I find out how much water actually went into the pipe? You integrate it from 0 to 8. Okay, you write down this, you get 1 point. You punch it in your calculator correctly, that's how you get the other point. That should be an easy 2 points. So, you know when you get these harder problems, you gotta get the points that you can get. Like this is, you have to get this one. Right? We know this already, right? If you are given a rate to find out how much was accumulated, you do an integral. B, is the amount of water in the pipe increasing or decreasing at time equal 3? So they're talking about the amount of water in the pipe. This is it. So how do you tell if the amount of water in the pipe is increasing or decreasing? How do you tell if any function is increasing or decreasing? You look at its derivative. Okay, so here, this tells you the amount of water. How do you take the derivative of that? What's the derivative of 30? 0. Now, how do you take the derivative of an integral? The fundamental sure the lower limit is a constant, and they both are. So what do? You take this and plug it in there, and you get R of t times 1, right? Don't forget to multiply by the derivative of that. And then what about this? How do you take the derivative of this? You take the t and plug it in here. You get d of t times 1. There you go. But doesn't that just make sense though? Shouldn't the derivative be this rate minus that rate? We call this the net rate. Doesn't that kind of make sense? Or if it's too confusing to you, just write this, take the derivative. You don't even have to like reason it out, but that's kind of common sense that this would be the net rate, right? This is the rate of the water going in, this is the rate of water going out, so the net rate would be the difference of the two, right? Anyway, so they're saying, is the amount of the water in the pipe increasing or decreasing at time equal 3? So they want you to plug in 3. What if this number comes out positive? Then it's increasing. If it comes out negative, then it's decreasing. That's how you tell, right? How do you tell if a function is increasing? Its derivative must be positive. How do you tell if a function is decreasing? Its derivative must be negative. So what you need to do is punch these things in on your calculator and see if it comes out positive or negative. I don't know what the answers are. I'm not going to take out my calculator. That's what you guys are going to practice. Okay, part C. At what time between 0 and 8 is the amount of water in the pipe a minimum? Oh, question.
Sorry, can you explain why you're finding the derivative?
Because it says, is the amount of water in the pipe increasing or decreasing? How do you tell if a function is increasing or decreasing? You look at its derivative. See, this is the amount of water in the pipe, right? So to figure out if it's increasing or decreasing, you gotta look at its derivative. This is the derivative. So you plug in 3, if it comes out positive, it was increasing. If it comes out negative, it was decreasing. So you gotta look at it. Whatever the function is, you look at the derivative. Does that answer the question? Okay, C. At what time is the amount of water, here, this is the amount of water in the pipe a minimum. So they're asking for an absolute minimum. So what do we need to do? The candidates test. Almost all of these problems are going to involve some kind of candidates test in there. So you gotta get good at it. I remember last year we had to do many quizzes because the students weren't catching on to the candidates test. So, and it really doesn't matter if they ask you for a maximum or a minimum. You do either one, you're gonna do the candidates test. So, what do I do for the candidates test? How do I figure out what goes on the number line? Or what goes on the candidates test? So time versus the amount of water. How do I figure out what goes in this candidates test here? The critical points and the endpoints. Well, does this problem, do I have to put the endpoints there? Look. Right here. From 0 to 8, including 0 and 8. Do the endpoints go on? Yes. If you don't include the endpoints, you automatically lose like half the points already. You have to have 0 and 8 on there. Now, what are the critical points? The critical points are when the derivative is either 0 or doesn't exist. Okay, so this is the amount of water. Look, we already took the derivative right here. This is the derivative. You have to figure out when this is equal to 0, right? So how do you do that?
RT equal to
Yeah, so what you gotta do is take this, subtract that, graph it on your calculator and see where it crosses the x-axis. Okay, I'm not sure whether you gotta do this. So you gotta go this, minus that, graph it on your calculator, just graph it between 0 and 8, wherever it crosses the x-axis, those are the numbers that you put over here, yeah.
I have a question. Wouldn't it be easier if you already have a and t to just like keep copying and pasting the function if it's only from like 0 to 8?
Say that again?
Like if you already have the function a to t.
Which is this?
Yeah. Like if you just keep on plugging in the numbers from 0 to 8 because there's only like.
Oh, you don't plug in all the numbers. There's an infinite number of numbers. You don't know if it's going to be a whole number. In fact, since this is a calculator problem, I'm guessing you're going to have decimal places over here. Yeah, you cannot just plug in whole numbers. Okay, but you know what? I'm going to this is kind of cheating, but it's really not. How about just graph this on your calculator? You know what I mean? See, what they want you to do though is they want you to analyze the derivative. So if you don't show that, see, the answer only gets you 1 point. So we can get the answer just by graphing this, right? And then picking, what do we want, the maximum or minimum? So I don't know what the thing looks like. So here's 0 and 8. What if the graph, I'm just saying, what if the graph looked like this? Then wouldn't this be the absolute minimum?
Yeah.
So you could actually graph this on your calculator. Oh, this is the lowest point, that's the answer. You might get 1 point for that. But what about the other 2 points? That's where this comes in. So you need the endpoints on your candidates test. And like I said, whenever this is equal to 0, that's what the numbers you put on the number line, right? Because isn't that what we normally do?
Yep.
Find out when this is equal to 0. So some of you are good at bringing up the scoring guidelines, although I gave it to you. Are you good? Is anybody looking at it? How many other numbers are there here? Do I have to walk to my desk? Anyway, once you get these numbers, remember now, when you write it down on your paper, you write 3 decimal places. However, when you punch it in, see, when you get this, you're going to have to plug it into here. You got to use all the decimal places. Because if you're off in the 3rd decimal place, point is coming off. That's like 33 or 1/3% of the problem. Anyway, so I'm not sure how many numbers there are. So each of these numbers, you gotta plug it into here. Look, 0 is easy, right? You plug in 0, shouldn't you get 30?
Yeah.
Right? Because the integral from 0 to 0 is 0. Anyway, they told us there's 30 gallons, whatever, at the very beginning, right? And then whatever numbers you have here, you plug it into there. And then, once you get all of these numbers, you just, well, let's answer the question. It says, at what time is the amount of water in the pipe a minimum? So whichever one is the smallest, let's say this is the smallest, then actually this is the answer, yeah? Because it says, at what time is the amount a minimum? Okay, any questions on that? So again, anytime they ask you for maximum or minimum, you gotta have the candidates test. I don't like it, but we're just gonna do what they tell us to do. And then D.
Wait,
Yeah.
sorry, quick question. So is it only when it equals 0, those are the critical points?
0 or doesn't exist. Yeah, because you could have shot points in the graph. Things like that. Okay, let's look at D. D sometimes is gonna get crazy, but like I said, well, let's read this. The pipe can hold 50 cubic feet of water before overflowing. For T greater than 8, the water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Right, but do not solve an equation involving one or more integrals that gives the time when the pipe will begin to overflow. Oh, I shouldn't have erased the darn thing. So what is the amount of water in the pipe?
30.
Was 30 plus the integral from 0 to T. What was the first one? R of T dt minus the integral from 0 to T of d of T dt, right? Okay, so it says right here, once it hits 50 cubic feet, it's going to start overflowing. So what's the equation they want then? Well, greater than or equal to 50, yeah? No, but they want an equation of equal. So that's it. That's your equation right there. When is the amount of water in the pipe 50 gallons?
Razor is from.
Yep. Is it gallons in this problem? No, it's cubic feet. Cubic feet. So you write that down on your paper. You don't even have to have this. You gotta have that down. I'm guessing that's either 1 or 2 points. But the C problem is minimum 3 points. Does anybody have the thing up? The scoring guideline? Okay, you just gotta guess that. Okay, so that's a typical rate problem. So, you're gonna, like, a couple years ago, they had people, this is the rate at which people are getting onto an escalator. This is the rate at which people get off the escalator. They always think, this is the rate at which a truck is bringing something to the quarry. This is the rate at which the rocks are being processed at the quarry. It's always like the same thing, like they have bananas. This is the rate at which people are putting bananas onto a stand. This is the rate at which people are taking the bananas away. They always have this problem, they just change it. But that shouldn't bother us, right? Okay. So tomorrow, what is tomorrow's quiz gonna be? Maybe we should do drills on that. The graph, oh yeah, okay, let's do some drills on that. Okay, we got 8 minutes left, okay. So the typical graph is they like to give semicircles and things. Okay, let's put the semicircle this way this time. Here's a semicircle, and then 3, 4, 5, 6. So when it, let's say it goes up like that, and it goes down like this. Okay, so this is -2, 1, 2, 3, 4, 5, 6. Okay, so the graph of f is made up of a semicircle and 2 line segments. G of x is equal to the integral from 2 to x of f of t dt. This is a typical graph problem. And then they're gonna start asking you all kinds of questions. How do you compute g of -2? And Dua's not, where did we leave off? That's okay, Duarte, how do I compute g of -2?
You plug in 2 for x, but then you have to.
What do you mean -2?
Oh yeah, -2 for x, but then you have to switch the limits and make it negative.
Okay, good. So since the smaller number's on the top, you gotta flip it, but then if you flip it, you gotta negate it, right? Okay, and then, Duarte, how do I compute that integral? If this is the graph of f, what does the integral from -2 to 2 tell you?
The area.
The area between the graph and the x-axis. So what is that area? It's half a circle.
Oh, 1/2 pi radius squared
1/2 pi,
r squared.
and what is the radius?
2.
2 squared. Okay, so is that your answer?
Yeah.
Okay, you lost the point. You know why?
Wait, why?
This area is below
Oh,
the
what
x-axis.
is
It counts negative.
So positive.
Yeah, because this kind of problem, it's either 0 or 1 point. So even if you know what you're doing, if you miss that minus sign, you're gonna get 0 points. So you gotta be very careful. Can I leave my answer like that?
Yeah.
Yes. You don't have to go on negative times a negative equals a positive. Okay, how do I compute g of 2 and Duha? This is g of x. So how do I compute g of 2?
2 to 3, f of t dt.
You need 2 to 2.
2 to 2, sorry, no.
Which is?
0.
Okay, that's the easy one. Okay, how do I compute g of 6? Well, obviously you plug in 6. Okay, now how do I compute this? Oh, how do I compute this integral? Henry, from 2 to 6.
1/2 times 2 times 1 plus 1/2 times 2 times 2.
Yes, it is 2.
Okay.
So that's your answer?
Oh wait, no. Minus.
Okay,
1/2
good.
2 times 2.
This area is below the x-axis. It counts negative, so this gotta be minus. You gotta watch for that now. This is super important. Okay, compute g prime of x. Who's next in line? Hobbs. G prime of x. How do I take the derivative of this?
F of t. F of x.
F of x. Okay, that's good. So that's the fundamental theorem of calculus part 1, right? How do you take the derivative of an integral? Make sure the lower limit is a constant, take the x, plug it in here, and then times it by 1. Don't forget to times it by the derivative of that. It's not always going to be 1. Okay, now, compute g prime of 2. Arakaki, g prime 2. good. Because according to this, g prime of 2 is equal to f of 2. And if this is the graph of f of 2 means when the x coordinate is 2, what is the y coordinate? Easy. What is g prime of 6 equal to? Tyler.
F of 6, which equals negative.
Yep, f of 6, which is equal to -2. Okay, who's next in line? Oh, Moroka. G double prime of 3. Compute G double prime of 3.
Do you take the slope of that?
Yeah, so you can go, okay, well, if G prime of x is equal to f of x, what is G double prime of x equal to? F prime of x. So therefore, G double prime of 3 equals f prime of 3. And what does if that's the graph of f, what does f prime tell you? The slope of the graph. So what is the slope of the graph when x is 3? So your eye should go right there. What's the slope of the graph right there?
It does not exist.
Does not exist. Very good. Why?
Because it's a sharp point.
Very good. That's it. That's what you say. Sharp point. Does not exist. Sharp point.
Could you find like the slope at like 1?
Yeah.
How do you do that? 0.
No, at 1. Right here. You mean like right there?
Yeah.
What's the slope? Okay, you know what? They're not gonna ask you that. I mean, they could, but then you're gonna have to like draw this and make it perpendicular. You know, like this is 0, 0, and then you gotta figure out this point. Then you gotta find the slope, and then you gotta do negative reciprocal. I mean, yeah, you can. Okay, but they usually not gonna ask you that. They'll go like here, compute. Who's the next one here? Get it later. What is G double prime of 5? Which is f prime of 5, which is? So in other words, where's 5? Right here. What is the slope of the graph right there?
Negative, wait, rise over run, right?
Or how about just do this? Okay, here's 6, -2. Here's 0, no, that's 4, 0. And then go y minus y over x minus x. Or you can go rise over run too, that works.
Negative 2, oh, yeah, negative 2 over 2.
Can you do my answer like that? Yeah, -1 is correct. What is G double prime of 0? Justin Lee. G double prime of 0. Very good. What is the slope at 0 right there? 0. So this is the kind of questions, and of course you could have a candidate's test in this too, right? Because they could ask you, what is the absolute maximum of G? Then we need a candidate's test. Question.
For these types of questions, are we gonna have to actually graph?
No. Maybe. I haven't seen that yet. They won't ask you for the whole graph. Maybe just the graph, maybe.
Like tomorrow you would like give us.
I definitely got like.
Well, this is the graph of F, but then they're gonna ask you questions about G.
Because I